Hey everybody, welcome to my channel. Today we're going to do the basics of lesson 1.1 in our algebra book, and this is the very first lesson in the book, and I'm excited to get it going for you. There are some vocabulary words in there that I wanted to bring to your attention before we get too involved in the lesson, and here we go. The first one is conjecture. A conjecture is something in math that you believe is true. It's kind of like a hypothesis in science. It's something you haven't proven yet, but you believe it to be true. You're studying something and you think that this is a true statement, and so you put it out there. This is my conjecture. This is what I think is happening, but you're not 100% proven in that. Once you're able to prove it, it's called a rule or a theorem. For example, the Pythagorean Theorem that states a relationship between the sides of a right triangle. It has been proven. The rule that, there's 180 degrees in a triangle or 360 degrees in a quadrilateral, those are proven rules in mathematics. Sorry about the bell there. An equation is a statement that sets two expressions equal to each other. So an equation has to have an equal sign, like right here, something very simple. Equation and equal both kind of start with the same letters. That's how I remember it. A linear equation with one variable will look something like this. You'll have an equation with an equal sign. You'll have a variable. That's the letter part. There's going to be something happening to the variable. It doesn't have to be adding. It could be subtracting, dividing, multiplying, squaring, square root, parentheses. There could be a whole bunch of stuff happening to it. And then there's always going to be something on the opposite side of the equal sign that it is equal to. The solution is the value that makes an equation true. So in my problem up here, I believe the solution is -7. Most of the time in this class, we'll have only one correct answer, but it is possible to have more than one correct answer. It's also possible to have no solution, but we'll get to that a little bit later in the year. Inverse operations are operations that undo each other, right? Adding and subtracting. If you add $5 and then you take away $5, you're back where you started. Multiplying and dividing are inverse operations. And then one that you don't always think of very often, squaring and then square rooting, that's the square root symbol, the radical sign there, those are opposites or inverse operations as well. Equivalent equations are equations that have the same answer or equations that have the same solution. For example, I just made these up. This top one up here has an answer of 2 because 2 plus 1 equals 3. The bottom one also has an answer of 2 because 2 times 2 equals 4. So I could say that these two equations are equivalent equations. Even though one is adding and one is multiplying, they have the same solution. So that's a quick little rundown of our vocabulary in this lesson. Now the actual problems are going to be solving simple one-step equations. So they're not going to be the most complicated. Let me go ahead and adjust my camera here. They're not going to be the most complicated. How should you think through these? If you're someone who's struggling, maybe this is the first time you've tried it, you're a little bit rusty, how do you just even approach these questions? Well, here's my help. I would say, number one, find the variable, right? The variable is the X, the Y, the W, the P, the K, the A, B, C, whatever letter, the unknown part. You're going to find the variable. You're going to ask yourself what's happening to the variable, and then you're going to undo that with inverse operations, right? So on number one, my variable's right here. It's the letter X. What's happening to the letter X is being subtracted by the number 4. How do I undo? What's the inverse of subtracting 4? And that should be pretty obvious. It's adding 4. And this should look familiar from last year. Now, whatever you do on one side of the equal sign, you've got to do the same thing on the other side of the equal sign. If you don't do that, if you give one side 4 and you don't give the other side 4, they're not balanced anymore. They're not equal. Think about like a scale in science class. If I put 4 pounds on this side, but I don't put 4 pounds on this side, I'm not equal anymore. Now I have a greater than and a less than situation. So if you put 4 on this side, you've got to put 4 on this side to keep it nice and equal. And so anyway, here, -4 and +4, those are inverse. Those equal 0, so you don't have anything left over here except the X. Here's where your answer is going to come from, -8 plus 4, and you can use a calculator if you're not that comfortable doing it in your head, and you get the answer of X equals -4. Now, if you really want to double check that, you're not sure, you're not certain if you're right, can I take my answer and go back to the original problem and substitute it in there and see if I make a true statement? Of course you can. You could say, okay, does -4 minus 4 equal -8? Just take your original statement, but instead of the X, substitute your answer in there and see if it's true. And you can type that in a calculator, you can work it out in your head, you can work it out on paper, and you'll find out that yes, this is a true statement, so we know we got it right. Okay. And that's going to be the process on all of these on this little board. On number 2, Don't let it bother you because the equal sign is here and the variable is on the right-hand side of the equal sign. That's okay. Don't let that throw you off. My variable is right here. What's happening to it? It's being added with 2.1. How do I undo? What's the inverse of adding 2.1? Okay, that should be kind of obvious. It's subtracting 2.1. And if you do it on the right-hand side, you've got to do it on the left-hand side to keep it equal. And so I'm going to subtract 2.1 over there. Over here, this is where my answer is actually going to show up, 1.5. The equal sign is still hanging out in the middle. Positive 2.1 and subtracting 2.1 equals 0. They are going to cancel each other out. And this is your answer. Now, every year I have a few kids who really get bothered by this, and they're like, well, wait a second. Is that the same thing as this? P equals 1.5? Of course it is. So I don't care how you write it. If you want to write it like this because this just looks more normal to you, but if you want to keep it like that, it's technically the same thing. Okay, the last one on this board, fractions. Don't let the fractions throw you off. It's the same idea, the same process. What's happening to the W? My W is being subtracted with 1/5. How can I undo? What's the inverse of subtracting 1/5? Well, that would be adding 1/5. And if I do that on the left-hand side, I got to do it over here on the right-hand side. And luckily, these are common denominators. 2/5 plus 1/5 is 3/5. The equal sign just drops on down. Negative 1/5 and positive 1/5 equal 0, so I can cancel those out. And then W equals 3/5 is my answer. And you could take it and plug it back in up here if you wanted, but these are probably easy enough that you don't really feel like you need to do that. Okay, I just have two more boards, just a few more questions, and then we'll wrap this one up. This board is all going to be about multiplying and dividing. Same idea. We're still going to undo things. We're still going to look for the variable. So on number 4, where's my variable? It's right here. It's the letter X. What is happening to the letter X? Well, it's in a fraction. Okay, yeah. What is a fraction really representing? It's not representing adding and subtracting. A fraction is a way of dividing, right? So this is another symbol for division. How do I undo dividing by 5? I'm going to say, okay, the inverse of dividing by 5 is multiplying by 5. So here's how my teacher showed me how to do it way back in the olden days, right? You can put 5 out here. You could even do 5 over 1 if you're more comfortable making it a 5 over 1 situation. And now over here, 5 over 5, 5 divided by 5, those two kind of cancel each other out, or 5 divided by 5 equals 1. So you just have 1x, which is good, because 1 times anything is just going to be your answer. Over here, negative 13 times 5 is going to be our solution, I believe. That is negative 65. A calculator could help me out. And then if you weren't sure about this one, because that answer does look a little bit bigger than the answers we had on the other board, you could take your answer, plug it back in right here, do negative 65 divided by 5, and see, if your answer is negative 13, which it is. I just threw my marker off the table. I'm just going to have to use this other one. Okay, on number 5, we have a decimal. Okay, there's no symbol. Do you see an adding sign, subtracting sign? I don't see any symbols in here, right? Remember, if there's no symbol between these, it's really representing multiplication. And so we're going to ask ourselves, okay, what's happening to the W? It is being multiplied by 0.35, by 35 hundredths. How do I undo multiplying by 0.35? Well, that's going to be dividing by 3.35. And so I'm going to do 7 divided by 0.35. This marker is not nearly as good as my other one. If you're not sure of yourself and you really need some help, you could use a calculator on this one. And I'm going to be honest, I'm thinking the answer is 20 or maybe 200, but I'm going to even use a calculator myself because I am not 100% confident. So I'm going to search over here off to the side. I've got my, computer. So I'm just going to open up the calculator on my computer, or if you have a calculator on your phone, you have a calculator, physical calculator with you. I'm going to do 7. I'm going to do divided by 0.35, and it is 20, so I was right, but like I said, I wasn't 100% confident. This purple is not working for me, guys. Let me switch it over to red. So 35 divided by 0.35 is 1. That can cancel itself out. 7 divided by 0.35 is my answer. And wow, this red is even worse than the purple. 20. These are markers that my kids used last year, and they are not cooperating. Okay, so that is that one. The next question over here, number 6. This one is really tricky, as is number 7. You're going to think this is a trick question, but it's really not. Okay, don't let the pi symbol fool you. The pi symbol is not a variable, right? The variable is the letter. Pi is not a letter. Pi is actually a number, right? It's 3.14. I could replace it with 3.14, but I don't really want to. That's going to be a waste of time. Right here is my variable. So I'm going to ask myself, what is happening to the letter y? The letter y is being multiplied by 3.14. It's being multiplied by pi. So how do I undo multiplying by pi? Well, I divide it by 3.14, which I'm not going to write 3.14. I'm just going to write the pi symbol. So whatever you do on one side of the equal sign, you do the same thing over here. So I'm going to divide this side by 3.14. And look how cool this one is. 3.14 divided by 3.14, or pi divided by pi. Anything divided by itself equals 1, no matter if it's a number or a goofy-looking pi symbol. Over here, you already have a pi to knock out that one. 3.14 divided by 3.14 equals 1. So this is really just 15 times 1, and we know 15 times 1 is 15. So basically the pi symbols just canceled, and you were left with 15. And I apologize again, this marker is pathetic. Okay, the last one. Same idea. Where is my variable? The only thing that's a variable here is right there, the letter x. What is happening to the letter x in number 7? The letter x is being multiplied by pi. It's also being multiplied by 2. It's being multiplied by 2 and pi. How can I undo multiplying by 2 and multiplying by pi? I can divide. What's the opposite of multiplying? It's dividing. This marker is pathetic. I'm giving it up. All right, I apologize, guys. We're going to and now this one's not even writing. I think it's just because I erased it so much. We're going to divide by 2 pi's. There's my dividing bar, okay? So whatever you're going to have happen to the letter x, multiplying by pi and multiplying by 2, I'm going to undo that. The opposite of multiplying by pi is dividing by pi. The opposite of multiplying by 2 is dividing by 2, the inverse. And so whatever I do on that side, I'm going to do the same thing over here. I'm going to divide it by 2, and I'm going to divide it by pi. And markers are pathetic. And it's this board, too. It's got this slime on it. Okay, so how can I solve it from here? 2 divided by 2, those cancel each other out. Pi divided by pi equals 1, those cancel each other out. You're left with your final answer down here, which is the letter x. And then on this side, 30 divided by 2. I know 30 divided by 2. 30 divided by 2 is 15. And pi divided by pi, the pi's cancel each other out. So my answer is just 15. So don't let that pi symbol throw you off. Usually in our book, at least right now, they're going to put a pi symbol on both sides, and so they'll just cancel themselves out. Okay, we have one last one. It is a word problem. Hopefully this board is a little more cooperative than the last one. A word problem, it says the temperature at 6 a.m. was 50 degrees Fahrenheit. By midnight, the temperature had dropped to -3 degrees Fahrenheit. How many degrees did the temperature fall? This says write. Write and solve an equation. Okay, so we started out at 50 degrees. We ended up at -3 degrees. They want us to figure out how far the temperature fell. Okay, it's not just as simple as it looks, right? How do you find out if something has lowered from one amount to another amount? How do you find out how much it's changed? You subtract them, right? So my equation is going to be 50 minus -3. Remember this, it ended up in -3. 50 minus -3, which that looks kind of awkward, so sometimes people put it in parentheses, equals, I'm going to put T for temperature, but you can put whatever variable you want. And then I could solve this. In case you don't remember from 7th grade, subtracting a negative is the same thing as some people do, leave, change, opposite, or some people say, hey, 2 negatives, these are both kind of negative signs, 2 negatives make a positive here, and they would put those as positives. It's whatever you want to think, if you want to do the leave, change, opposite thing, or just 2 negatives make a positive, and basically change this to 50 plus 3, you could get your answer. And so the temperature has dropped 53 degrees Fahrenheit. Okay, there's my answer. My equation, I kind of scribbled all over it, and that doesn't look so nice anymore. So my equation would be what we wrote originally. Here's my equation. 50 minus -3 equals T. See how I have, when you do an equation, you have to have an equal sign, and you have to have something on both sides of an equal sign, right? Just writing this is not an equation. Right? 50 minus -3. No, that's not good enough. Just doing this is not good enough. That's an expression. That's not an equation. When it says write an equation, you need to have an equal sign, and you need to have something on the other side of the equal sign. And in this case, I picked the letter T, but you could have picked any letter you wanted. All right, guys, I'm going to stop right here. Be checking my Google Classroom because I will post the assignment and which questions I'd like for you to try and how you can get there and find them. So I hope you do well on this. If you have any questions, don't be scared to email me or ask me. I will do everything I can to help you. So check the Google Classroom for further instructions. Thank you so much, guys. I'll catch you in the next one.